Let's say you want to build an alarm system. Now, like for the sake of an example, let's take a fire alarm system. So you have some kind of fire and you want to detect whether the fire exists, and if yes, sound a speaker. How do you connect between these two is the question. Let's say we have some measure of measuring what this fire or temperature is, and then we compare that temperature to some level of fire temperature, and we can say that if this level of this temperature is greater than this level, if yes, then fire. Okay, so what's important here is to notice that we have something called a comparison here, which we need to do to make this work. Now, in real life, there is no way for us to check whether temperature is higher than a particular temperature unless there's a human out there. And we want to make this a machine without needing a human presence. So what we do, like almost every other problem, is to convert the problem into another problem. So we convert this fire or temperature into a voltage. We also convert this level into another voltage. And now our problem changes from measuring and comparing temperatures to measuring and comparing voltages. And this comparison of voltages is where an operational amplifier or an opamp is going to come into the picture. To make this system a little better, let's say you didn't only compare the temperature, but you also wanted to take into account that it's actually that hot and it's not simply the weather. So now what you want to do is that you want to sense the temperature and you want to subtract room temperature from it. And after you have this result, then you compare that result to fire voltage. Again, we convert everything to voltages, and so now another new problem that we created was subtraction of voltages. These kind of operations, if you want to do with voltages or currents, that's where you need operational amplifiers. What are operational amplifiers? An operational amplifier has two terms, operational and amplifier. Let's first look at the term amplifier. An amplifier is anything which will take an input and the output will be larger. It will be an amplified version of the input. So you can think of an amplifier as a box. Generally, an amplifier will have one input and the output will be a magnified version of the input, in the sense out is equal to sum A into in. But in the case of an operational amplifier, instead of one, we have two inputs. We call them V plus and V minus. The same gain A exists and we have something called an output voltage. So what this amplifier does, it's specifically called a differential amplifier because it subtracts the two input voltages and multiplies them with the gain A to produce the output voltage. So what we get in the end is V out is equal to this gain A times V plus minus V minus. Now the other term that you can see in the name is the word operational. What kind of operations are we talking about? All the mathematical operations that you've seen so far. Addition, subtraction, multiplication, division, exponentiation, logarithm. Almost any operation you can think of, any mathematical equation that you want to implement, it is basically made up of individual operations, and we want to implement these individual operations in electronics. And that's exactly when an operational amplifier comes into the picture. So, to get a brief overview of what we've just said so far, the real world has some signals or information. Like in our example, this was temperature. We then want to convert these real world values into current or voltage, which are the electronic values that we know how to handle. Then once we have current or voltage, we want to further do some mathematical operations on them called some kind of processing or operations, which is where our opamp comes into the picture. Then the output of that processing or operation is again going to be in the form of current or voltage. And then we want to convert that current or voltage into the real world again, which in our example was sound, the sound of the alarm system. You might wonder why we need all this when we have computers out there to do all of these calculations and comparisons and all kind of other operations. But well, a lot of things are hardware, not software. And when you have a hardware device, putting a computer, often called a microcontroller there, is quite bulky and expensive. And doing that for a couple of operations is plain stupid. And so, in those cases, when you have a few operations to be done, especially in the analog domain, we prefer to use operational amplifiers. So, that's the need of operational amplifiers. And in the next section, we'll look at what the block diagram of an operational amplifier looks like.